Welcome to week 10. This is the first lecture in week 10. We're now switching from mechanical considerations to lighting considerations. In this first section, we're going to be looking at some lighting definitions. A little bit of background first. Lighting is actually really important when looking at energy audits because in a lot of commercial, not necessarily industrial or manufacturing, but in commercial buildings, lighting forever has been one of the largest energy uses. So lighting is something that we have to look at. Now, lighting's more complicated than it seems. Now, everybody looks at lighting and goes, wow, low-hanging fruit, cherry pick it. I'm here to tell you it's not just about the energy it uses. So if you don't remember anything else after we talk about lighting, remember that it's not just about the energy, even though that's what the government tells you it's all about. Lighting is a lot more complicated. So before we move on, I want to give you a quick scenario of how complicated it can be. A number of years ago, I was involved coming in after a facility manager, a new facility manager, came into a facility and decided on his own accord that he would come in on a weekend and make a wholesale replacement of the general lighting in this facility. Now, at the time, this facility literally had thousands of old T12 lamps. This person went from the old T12 40-watt fluorescent lamp to a T12 34-watt. So that was what was being accomplished. But literally thousands of lamps were being replaced in this industrial facility. And it happened over a weekend. Now, about a month later, this facility manager was called in and was terminated. Now, what had happened was this facility made a product out of leather, and at some point in time they manufactured a number of products out of leather, and they were rejected by the purchaser. So a large shipment of something made out of leather was rejected. When the company looked into the lack of being able to pass quality assurance, they discovered that the area where the leather was being graded had the wrong lighting in it. It turns out when they did this lighting replacement, this one area where leather was graded actually had very special fluorescent lamps that gave a full spectrum of light so the leather could be properly graded. The facility manager didn't realize this and replaced these lamps with just standard fluorescent lamps, which do not have a full spectrum of light. Consequently, the people grading the leather in these areas graded a bunch of leather wrong because the lack of full spectrum light impacted their grading. And in the process, the company lost a lot of money because of the rejection of this product, and the facility manager lost their job. So in the essence, they were trying to go from a 40-watt lamp down to 34-watt, basically save 6 watts per lamp, but thousands of lamps. It seemed like an innocent thing to do, but it turned out the lighting in this situation was a lot more complicated usage than simply about the energy that it was using. So be really careful. Typically, if I have complex lighting issues, I get a lighting expert in because it can be tricky. So, we just talked about it's not just about energy. Well, when we look at lighting considerations, we'll put energy at the top, energy use. Now, the efficiency of a lamp is called efficacy. It's lumens per watt. So lumens is the light output out of a lamp. In other words, how much light does a lamp put out, divided by the wattage that goes into making the light out. So that's lighting efficiency, or lamp efficiency, is called efficacy. lumens per watt. The next thing is color rendition index, also known as CRI. Color rendition is the ability to distinguish various shades of color under that particular lamp. Gets very tricky when we're dealing with subtle shades of the same color. Think surgery. Think opening somebody up and we have various shades of red. It'd be nice to be under a type of lamp where you can actually distinguish various shades of the same color. So color rendition index is an index from 0 to 100. 0 meaning I can't distinguish any color, all the way up to 100 meaning that I can distinguish the finer shades of even reds, blues, whatever. So 100 is a perfect color rendition, 0 is the total lack of. Then we have all the costing issues. How much does the lamp cost? How much does the fixture cost? How much does it cost to dim the lamps? How much does it cost to dispose of the lamps? Another big thing, lifespan of the lamps. How available are the lamps? Can I easily get a hold of them if I need them? Continue on with lighting considerations. What's the environmental impact? Is the lighting hazardous? That type of thing. Environmental impact to the surroundings. So we have two environmental impacts. The environmental impact, does the environment impact the lamp itself? So that's a two-way street. So we have the impact to the environment of the lamp as far as it contains mercury or we cause light pollution with it. The other one is, does the environment itself impact the lamp? So is the lamp sensitive to heat? Is it sensitive to cold? How does the lighting impact the architecture? Does it enhance it? Whatever. How does the lighting impact productivity? What kind of mood does the lighting create in the plant? Finally, there's a lot of qualitative issues when it comes to lighting. Typically, lighting can be used to set a mood, a feeling, a condition. The cosmetic industry uses this, the entertainment industry, the restaurant industry. You name it, there's a number of industries that actually use various types of lighting to actually set moods or conditions to get you to cough up more of your hard-earned cash doing something. How easy is it to turn on and off the lights? Does it have a rapid on-off? In other words, when I get at a switch, can I turn the light on? I get light right away. If I turn it off, I can turn it back on right away. So how quick can I turn it on and off? So a little bit of background, what is light? Depending on what we are doing, it's either an electromagnetic wave or it's a particle. We're going to discuss the wave part. So visible spectrum of wavelengths from longest wavelength to shortest, and I'm sure you had this in a physics class for any of you that have had physics, is red, orange, yellow, green, blue, indigo, and violet. The Roy G. Biv. Red being the longest wavelength, violet being the shortest wavelength. That's the visible spectrum. The red, orange, yellow light region typically give humans a warm feeling. So, I mean, that's the qualitative issue of this. We see red, orange, yellow, and it has a warm feeling to this. This region also has a flattering effect on human skin tone. In other words, those colors have a tendency to make humans look well. Of course, this is taken advantage of by the entertainment industry, the cosmetic industry, and the fashion industry. Of all the lamp types we're going to be discussing, incandescent lamps typically give off light in this region. So most incandescents give off light in the red, orange, yellow region, depending on the wattage. And this is the same region that's very flattering to human skin tone. So there's a lot of industry that uses incandescent lamps because it enhances or makes their business better. The blue, indigo, violet region give humans a cold feeling. This region is not flattering to human skin tone. The fluorescent lamp category naturally give off light in this region, and we're going to discuss that in a little bit. The color temperature is a rating in K value. All lamps have a K value, and it's a measure of the color temperature. The lower the K value, the warmer the feeling. So if you get down in the 2000 region, you have a very warm, fuzzy, like the incandescent lights, and if you get higher numbers, 4,000, 5,000, 6,000, you're mimicking more what fluorescents give off, that cold, cooler feel. So K value, or lighting temperature, the full range is about from 1700 down in the ultra warm region up to 15,000. So some of the more common temperatures, like a standard incandescent lamp has a K value of about 2,400. If we move up the scale to 3,000, that would be the classification for a compact fluorescent lamp or an LED that's rated warm white. Now if you look at it, it still has sort of a warm light yellowish feel. It's an effort to mimic about a 60 watt incandescent lamp, and again it has a K value of about 3,000. 5,000 gives you daylight. It's more of a white light. Common fluorescent lamps, it can actually, if you look at it under certain conditions, it has a little bit more of a colder feel to it. And then 6,500 overcast daylight gives you a real strong, cool feel to it. Now, all lamps in a space should have the same K value. Otherwise, when you look at the lamps, you have everything from a yellow color to a blue color to a white color. So typically, humans like it if all the K values are the same in a particular area. Lamp light output. The amount of light put out by a lamp is known as a lumen. The lamp efficiency, as we talked about before, is how many lumens a lamp is put out by how many watts that you put into it. So lumens per watt is the efficiency or efficacy of a lamp. Now, not all the lumens put out by a lamp make it to the spot where we need it. That's unfortunate. The work surface is where we want a certain amount of light. So, any light that leaves a lamp and makes it to the work surface without hitting anything else is called direct lighting. So if it goes straight from a lamp to our work surface, it's known as direct lighting. If the light bounces off something first, such as a wall, ceiling, another object, it's known as indirect lighting. It's actually being reflected to get there. So lighting hitting something will do one of three things. Light hitting an object could be absorbed, depending on the color of the object. Lighting hitting an object could be reflected, depending on the material and the color of the object. Or it could be transmitted. Now this only happens with objects that are not opaque. They have to be clear, such as a window. So light hitting a window, a little bit might be absorbed, a little bit might be reflected, depending on the angle of the light source, but most of it is transmitted through. Now, ultimately, light that finally manages to make it to the work surface is a measurement called Footcandle. Now, Footcandle is the imperial measurement, or the American standard measurement. The metric version is called a lux. 1 Footcandle is equal to 10.9 lux. So it's about a 1 to 10 between American standard and metric. So a Footcandle is the measure we use to determine if the level of light is appropriate for the task being worked on. So really, code comes into play here. We require a certain amount of light at our work surface to meet code. And that measurement is either in Footcandle if we're using American Standard, or Lux if we're using metric. The organization, the professional organization that covers lighting standards, is known as the IESNA. This stands for the Illuminating Engineering Society of North America. It's sort of like our ASHRAE. They set standards on levels or foot candles of light and purpose or function of the work area. So they combine those two. And trust me, their book is, it's got to be 8 inches thick. It's huge. And they have every possible task on the planet. So you can go through and find any mundane task, and they will give you a range of acceptable foot candle of light at that work surface to accomplish that task. So the appropriate level of light can be a combination of a number of different sources. So foot candle of light at a work surface can come from a number of different areas. It can come from general lighting, in other words, lighting that's fixed to the building. It can come from task lighting that's actually fixed to the work area or on the equipment. Or it actually can be natural light, in other words, coming from skylights, windows, etc. Or any combination of the three, as long as we're getting the appropriate foot candles at the work surface that would meet code. Things that impact light level: age and the type of lamp. In other words, certain lamps give off certain types of light in certain directions. As a lamp ages, it typically starts giving off less and less lumens compared to the wattage put in, so the efficacy drops. The maintenance condition of the lamp and fixture. Lamps and fixtures, also known as luminaires, should be cleaned periodically. That rarely happens. So as dirt and dust accumulate on the lamps, the light output changes. The layout of the fixtures are critical. That's why it's typically done by a lighting expert. The type of fixtures will impact how the light is being directed to the work surface. The maintenance condition of the reflected surface. So not just the lamps and the fixtures are important, but when's the last time ceilings were painted, that walls were painted? If this was taken into consideration when lights were first put in, that a certain amount of light was going to be reflected off ceiling and walls, and they haven't been painted in years, that will also reduce the light level. And then variations in natural light. How are we taking into consideration that? Other lighting terms, we call light bulbs bulbs. Actually, a light, the bulb itself is actually called a lamp. The fixture the lamp is put in is actually known as a luminaire. So we go out and purchase a lamp, and we come in and we put it inside a luminaire. Direct light can cause glare, which is not a good thing for some tasks such as sporting events, reading, detailed work. So typically we try to avoid glare. It's direct lighting actually bouncing off something or directly coming into our eyes because we're looking at the light directly. This ends Lecture 10A. When you're ready, you can proceed to Lecture 10B. Thank you.